Welcome back to my channel. In this video, we'll see what is adjacency matrix and adjacency list in data structures and algorithms. We know that the matrix and we know the list, but here is a concept is adjacency list and matrix. The graph when represented using sequential representation using matrix is commonly known as adjacency matrix. Means what? Here we are representing the vertices of the graph into the matrix. And you can represent the adjacent uh, nodes or the connected nodes to particular nodes in the form of rows, in the form of linked list. In adjacency list representation, then n rows of the adjacency matrix are represented as n linked list. So let's see the example. Here is the one undirected graph. Here direction is not given. So how to create the matrix of this graph? So this is undirected graph and here is adjacency matrix. So how to create this adjacency matrix? First list out all the vertices. How many vertices? 3, 4, 5. So write the names of these vertices here. Then here also in a row and in a column write the name of these vertices. If the age present between A to B, then note down, see, in a row A to B, list out the 1. Also, you can consider the B to A also. This B to A also. So here is the 1. Okay. Then, which is next stage, see, A, D. From the A, we'll consider the first A vertex, then B and then C. Okay. A to D. So, in the A row, at the D, mark 1. If the age present in between these, then mark it as a 1. Otherwise, write all is 0. A to A, there is no self loop, so 0. A to C, age is not present. A to C not present, so write the 0. A to E, age is not present. Again write the 0. Next, consider the vertex B. B to A, age is present, so mark 1. B to C, present. B to D, present. B to E, no. So write the 0. Consider the next vertex is C. Then C to B, age is present, so write 1 here. C to E, age present, write the 1 here. And so on. So you can represent the undirected graph into adjacency matrix in this way. Take the next example. If the direction is provided, see, here is a direction, means A to B only. Okay, A to B only, not from B to A. Okay, in previous example, when you are representing A to B, here you can write the 1. And B to A, you can consider this B and here A and you can represent 1. But here direction is provided. So A to B only, not from B to A, because direction is from A to B only. Next, consider the B. So B to C is a age present, B to D is present, B to C, and B to D. So in this way, you can represent the adjacency matrix of the directed graph, because here direction is given. Next is weighted directed graph and adjacency matrix. See, in this example here direction is given. So you can mark here the 1 if the age is present. But the weight is assigned to this age, then at that time you need to write the weight at that location, means A to B. A to B, write the weight 4. Then B to C. B to C, write the 2. Then B to D is also present with the weight 1. B to D is 1. So in this way you need to write. Then C to E 8. C to E 8. Okay, here is 8. So you need to represent the this. If the age is present, write the weight of that age in the matrix. Here is adjacency list. Undirected graph is given. Here, when you are creating the adjacency list, so at that time you need to create the first header. Okay, header means what? This node. Okay, list out all the vertices in a header from A to B. So A to B is present, A to D is present, both edges. So write this first node A to B, next A to D. So write the D here and you can specify the aim of this list in this way. Consider the vertex B. How many vertices adjacent to B? A, D, C. So write the A, D, C. Three vertex adjacent to this B. So three elements will be there in a list. Consider the C, B and E. Two vertices. So B and E. So in this way you need to represent all the adjacent vertex of this graph. Okay. Next, here is also the one more example of undirected graph. So here also, how many vertices? 4, 0, 1, 2, 3. Okay. Here is 3 is connected to only 0. So write the 3 to 0 only. Okay. Then 0 is connected with 1 and 2. So 0 is connected with the 1, 2 and 3. 3. Okay. 1 is connected to 0 and 2. 0 and 2. 2 is connected with 0 and 1. 0 and 1. So in this way you can represent. Here, if the directed graph is given, how to create the adjacency list? See, direction is specified now, so write just A to B, just one node. So A to B only. Then B to C and B to D both are outgoing edges. So write the C and here D. Then C, you can write the D first and then C, no problem. You can write. Okay. Then C, consider the C to E is present. So write the C to E also. Then D to A is present, D to A. E to D is present, write the D here. So you can create the adjacency list in this way for the directed graph. Here directed graph is also there and the weight is assigned to this age. So, see, in this example we learned, we just given this A to B. But now, here, when you are going from A to B, write the B also and the weight also. Okay, here we will use the two data field in this list. B and weight is 5. C B to C. So write the C name of this node and the weight assigned to this node. Then B to D. Name of the node D, weight is 8 and then specify the null. Then E to D and then null. So this is weighted directed graph for weighted directed graph and the adjacency list for respective graph. Thank you. And if you have any query regarding this, please write it in the comment box.